the goal for today is to be able to do some mixed factoring and factor polynomials using all of the methods that we have learned so far. And we've only learned 4 methods, and plus GCF if you consider that its own method, and you'll be testing for it for the first time on Thursday. And the first test, I imagine, will be easier because how can you check your answers for all factoring methods? By distributing and or foiling. So then I imagine the multiple choice should be easier then, because if you really have no idea what you're doing, at the very least you can multiply the answer options and see if it equals to what the question is asking. But on Tuesday, so far, your open response test is scheduled, your retake. So really, I would say prepare yourself for Thursday. I mean, you really should always be taking the first attempt at the test seriously because you only get 1 retake in class. So that Thursday, I think, will be easier, especially because you get to use your notes too. And the graphic organizer that we're going to be filling out today should be really helpful with that. But for that retake, keep in mind that it's free response. So let me actually show you the review sheet for it. I'm having the review sheet printed, so I don't have it for you today, but I should have it for you tomorrow. But if you look at it, is there a single multiple choice question on there? All right, no, they are all open-ended so that I can give you points for maybe if you got one of the steps right, like maybe you got the GCF right, or maybe you have the majority of the problem right, but maybe you just put a wrong sign somewhere. All right, so the Thursday's test just grades you on if you're right or wrong. This one I can give you partial credit for, so you show as much work as you can. So just keep that in mind. You do have to learn all the methods, and on your retake, you only get to use your correction sheet. All right, but if you can keep this graphic organizer, even memorize it, then I think that would be your best bet in getting a good score. All right. So first thing that you're going to do always, sorry, I zoomed in so that way when I write on here, it's not as hard. But the first thing that you're going to do is always look for a GCF first. All right. Sometimes after factoring out a GCF, you're done. So that's what the first portion of your open response test will be. It's just factoring out a GCF. But you always still check the parentheses to see if they can be factored out further. And if they can, or maybe there's no GCF, then you look at the number of terms. So when it's 2 terms, we only learned one method that involves 2 terms, and that's difference of squares. So if it's not a difference of squares, can you factor it more? So say you factored out the GCF already, and it's not a difference of squares. Maybe it's adding them together. So if there's a plus sign in between here, can I factor it? Not using a difference of squares, because what does difference mean? Subtraction. All right, and then squares mean that it's a perfect square on each side, so you can find the square root of them. So then you factor it according to this rule. What's the square root of a squared? So I have a plus b in parentheses and a minus b in parentheses. That's how you factor a difference of squares. So if it's not a difference of squares, then don't use this rule. But if it is, you'll know because it's 2 terms, subtraction, and a square on each side. All right, so if it is, then you factor it. So in this first example, is that a difference of squares? X squared minus 64. Yes, so then factor it using this rule. What's the square root of x squared? And what's the square root of 64? So I get x plus 8 in parentheses and x minus 8 in the other. And then when I FOIL that, I do get the x squared minus 64. All right, so any questions on this first example? All right, the difference between this one and the one underneath it is what? Is it a difference of squares necessarily? No, but that's why it always says as your first step that you need to look for a GCF first and then see if you can factor further. So is there a GCF in this one? What is a GCF? Can I factor out any variables? Just one n. All right, I can't factor out an m because they both don't have one, but they both have at least one n. So that's what I can factor out. All right, factoring it out means that you're dividing it from each term. So I'll do the scratch work over here. 18m squared n minus 2n cubed. Divide your GCF from each term, 2n. What's 18 divided by 2? M squared basically divided by 1. There's no m squared or m underneath, so just m squared. And then what happens to n over n? Cancels out. And now we're on to the next term. What's negative 2 divided by 2? And it's negative 1. And what's n cubed divided by n? N squared. All right, so before I box this up and say that I'm finished, because sometimes you are finished after that step, after factoring out a GCF, then you check the parentheses. Can I factor this out further? Is it a difference of squares? Is there a minus sign? Are there perfect squares on each side? Yes. So then, yes, continue factoring using the difference of squares. So then 2n, your GCF will stay part of your answer outside the parentheses. The parentheses itself can be factored using this rule. So what's the square root of 9m squared? Sorry, hold on. Square root of 9m squared is 3m. And the square root of 1n squared is what? N. I'm sorry, I meant to put an n here. 3m plus n will be one of the parentheses. What will be the other? 3m minus n. Let me make this look more like an n. But then that is your answer. Questions on these two examples? All right then. So the trinomial terms, when there's 3 terms, is next. So after looking for a GCF, if you factor it out, or maybe there's no GCF, in your parentheses or in your problem, there's 3 terms set up in this form, ax squared plus bx plus c. Then you use one of 2 methods. One where you just use the diamond method, and one where you use a diamond method and a few extra steps. All right, so what is this one over here? It's when do I just use the diamond method? When a equals 1. So they even basically put a 1 there. When a equals 1, you are just using the diamond method, which is what this is describing. All right. It's a times c on top, which will be 1 times whatever number is in the c position, and b on the bottom. And then that's it. So for the first example, a times c, 1 times negative 42 gives me all right, the longer that this takes, the less time you have to practice. You don't need your Chromebooks today. You can close them. And you can stop staring at your phone and you're off. So again, a times c, 1 times negative 42. What's that? 1 times any number is what? That number. All right, so negative 42 goes on top. What number goes on the bottom? A number goes there, not a variable. Negative 1. All right, and then how do you complete your diamond? They need to multiply to the top number and add to the bottom number. 42 has a number of options for what multiplies to 42. We have 42 times 1, 21 times 2. What else multiplies to 42? 6 and 7. Which of these combinations could potentially give me a negative 1 when I add them? 6 and 7. And since it multiplies to a negative and adds to a negative, which one has to be the negative number? Good. All right, once you figured out the two numbers that make your diamond work, you just write your answer as a product of two binomials. So x plus 6 and x minus 7. So questions on that example? And then when you FOIL it out, you do get the original problem. All right, now down here, we have it where a is not 1, right? I taught you how to solve problems like that. But what should I really be doing first? Because if you skip that first step, and you just jump into the diamond method the other way that I showed you, you won't necessarily get the right answer. Look for a GCF first. Do I have one? What is it? So then factor that out, meaning GCF goes outside parentheses. Divide each term by 2 on the inside. Do that on your paper real quick. Don't just wait for me to write it. I want to know that you know how to factor things out. All right, and then if you factored it out correctly, you get w squared plus 10w plus 25. So dividing each term by your GCF. Now, once you've done that, check the parentheses. Can I factor the parentheses further? Yes, because look, count how many terms you have. 1, 2, 3. There's 2 options. All right, we already discussed this one, and it is in that form. All right, leading coefficient is 1. It's in the form ax squared plus bx plus c. So you use your diamond method on that. What number will go on top of your diamond? And what number on the bottom? 10, that's a 10. Not an 18, that's a 10. And what two numbers multiply to 25 that add to 10? 5 and 5. Both positive? Yes. So then you get 2, your GCF outside parentheses, w plus 5 times w plus 5. Be aware that you might also see this as an option on the test, W5 or W plus 5 squared. Because they're exactly the same, right? Same sign and everything. So this is another way of writing that. Questions on this, on these, the first two methods we learned. All right, so then that gives us 15 minutes to go over the last two. All right, now you look for a GCF first. You see that there's 3 terms, and it's a trinomial in this form, but this time it's when A is what? When A is greater than 1. I'm just going to put not 1. So when A is not equal to 1. So like that. Not equal to 1. It says use the slip and slide method. There's tons of different names for it. All right. Slip and slide, slide and divide. I think the best way that I've taught you is still the diamond method, but then there's a few extra steps which we'll draw off to the side here. All right, so first step, you set up your diamond. Well, actually, what's the real first step always? Look for a GCF first. Because if I just went straight into setting up my diamond, so A times C on top, B on the bottom, 30 times 6 is 180, and then negative 27 on the bottom. Would that be a good use of my time? Probably not, trying to figure out what number multiplies to that and adds to that. So that's why you do the GCF first. What's the GCF in this problem? So factor out a 3. Do that on your paper real quick. Give you like 10 seconds before I put it up on the board. If you factored the 3 out correctly, you get 10x squared minus 9x plus 2. All right, so divide 3 from each term. Now is when you check the parentheses to see if you're finished. Can I factor it? Yes, you can. And so the steps we're going to write over here. So first is you set up your diamond. A times C on the top. So what's my A times C in this one? 20. 10 times 2. What number on the bottom? A negative 9. And then some numbers that multiply to 20. You can always make a list if you're not sure. Which combination can possibly give me a negative 9? And since it multiplies to a positive and adds to a negative, these both have to be good. All right, so now my parentheses so far are x minus 5 and x minus 4. Now, am I finished? No, because if I FOIL out what's in the red so far, x times x, does that give me 10x squared? So that's why there's a few more steps after just doing the diamond when A is not 1. So first is a diamond. Second, do you guys remember? Good. So that's why sometimes they call it slide and divide. All right, because they slide that A over, multiply it by C, but then you have to divide it to get, that leading coefficient. That's not 1. So we're dividing by A. Step 3 is to reduce the fractions. So what does 5 over 10 reduce to? Don't flip it. I know you like the bigger number to be on top, but it's not. So what does it reduce to? Good, 1/2. And then 4/10 reduces to 2/5. And they were minus, so I'm keeping the minus. Question so far? All right, after reducing, you know, if you get a whole number, then great. If it reduces to a whole number, then you just leave it there. But step 4 is to slide any remaining denominators. So slide denominators is what I'll write for shorthand. So in this one, I happen to have to slide twice. I have to slide that 2 and this 5, and then rewrite it. Your GCF will be there always, but this will rewrite to 2x minus 1 and 5x minus 2. So just slide it in front. And now when I FOIL that, 2x times 5x, isn't that 10x squared? Yes, and then you keep going, and then you do get everything in the parentheses. Questions? All right, and then if you were not here Friday, we learned how to factor by grouping. So definitely check out that video, or maybe one of the shorter ones that I linked in the slides, because that's the last step we learned. So if you check for a GCF, maybe you factor it out already, and what remains is 4 terms, either in your parentheses or in your problem in general. You get 4 terms, then you factor by grouping. And I'm just going to kind of add similar terms. All right, by grouping similar terms. Because sometimes the similar terms are right next to each other. Like you can just do the first 2 and the last 2 terms. But sometimes they're not right next to each other and you have to like rearrange it. But you group your similar terms together, and there are multiple ways that you could group stuff. Like maybe you group it differently than your friend and you still get the same answer. So just keep that in mind too. But in the blue group, I'd say those are similar because they both have multiple A's. So what's my GCF of the first group? A squared is correct. So first step is group your similar terms together. Second step is factor out the GCF from each group. So here's my GCF of the blue group. What's 2a cubed divided by a squared? 2a. And then negative a squared b divided by a squared. What do we get? Negative b. So 2a minus b in the parentheses. All right, now factor out the GCF from the red group. What's the GCF of that one? All right, it is 5. And sometimes you might have to play around with the sign that's on that 5 because your goal is to get a common binomial. So last hour they thought a -5 is what you factor out. But if I did that, I would get a negative 2a and a positive b. You want it to match up completely. So that's why it has to be a +5 in this one. So that's why I say do it in pencil, because you can always erase it and adjust. But what's 10a divided by 5? And negative 5b divided by 5? Negative b. All right. So you should have a common binomial, and we do, 2a minus b. That will be part of our answer. What will be the other part of our answer? Good. So the leftovers, if you want to call them that, or the GCFs. So here is our common binomial. That's part of our answer. And here is your GCFs. They get their own parentheses. Because now when I FOIL them completely, I do get the original problem. Maybe in like a little bit of a different order, but I still get it. So any questions on this one? All right, so let me go back to the slides for a little bit. So we completed our graphic organizer. Here's just a couple other announcements. I will link the lesson that we just did together in here. The review sheet, I'm getting copies made of that, but if you want to get a head start on it, it is in Schoology and it looks just like your retake. All right, if you can do the review sheet, it'll still be really helpful to you for your first attempt at the test, even though it's just like the retake. The mixed factoring practice, I am also getting copies made of that. So I do have some copies here in class, but not enough for all of you. Hoping that the TA comes and brings it here in a second. And here's the testing schedule for this week. So we're taking the topic 7 test this Thursday. Your binder check will be Friday, so I'll put the list in the slides sometime this week. And the deadline for late work from the pink folders is also this Friday. So just get your late work turned in. Any questions? All right, tomorrow we'll have time to work on